Okay, I think it's time. So everyone who wants to know something new or fascinating about an access is here. So what I'm going to talk about, when you write in access, you a lot of times resort to either reading core documentation or to looking at other people's code. Since what is presented in Perl Guards, Perl API is doesn't always contain all the information you need. So a lot of code ends up being copied from other people's code, and it's not always optimal. So today I'll tell some things that will help you to write code faster and spread faster access to the world. So, what's the most important thing when it comes to optimization? Any ideas?
Not doing things you don't need to.
But how do you know which things you don't need? Yeah, profiling. So, at first you need profiling. Then you need more profiling. It's never enough profiling you can have. And finally, choosing proper algorithm. Since sometimes you just can't do things you want to do in the way you are doing. So, if you profile a typical Perl application, what you will see to be the most executed function from the Perl interpreter. The top three functions are most commonly those three. Sometimes you will see clear there or something else depending on exact load, but those three are universally most executed. And if you wonder about your application, how can you obtain this top, the Linux command perf top is an ultimate tool for this. It shows live what's happening on your server. So, of those three functions, HV common is the most interesting. Everything in Perl is stored in hashes. All your data is stored in hashes, and packages are also special kinds of hashes. So it gets called a lot. And the most basic way to screw your performance is to call it incorrectly. And there are lots of ways to indirectly call it. Using all those stash manipulations, those are stash or glob manipulation routines, and this is hvfetch, the basic proxy to hvcommon. And hvcommon has a strange API. A lot of parts of the Perl core has strange API. It accepts one parameter, but which can be split into two parts. It can either be an scalar value, just any scalar value, or it can be a character plus length plus some flex triple. So, what's the speed difference between two of those interfaces, and why is it so large? So this is 3 snippets of Perl code, pure Perl code, and one of those snippets runs significantly slower than the other two. What do you think? Which one runs slower? Anyone thinks anything else? Or the middle one? But why? The last one has even more operations than this. Yeah. And one way to determine the Perl program speed in the first assumption is to check how many instructions does it have. But it happens that in those, for example, in those first two cases, second one executes twice as more instructions as the first one, Perl level instructions, but it's twice as slow in the first and the third. Since for long keys, rehashing operation when accessing the hash is the longest part. The longer a key is, the longer hashing takes. And in the third one, I've tried to extract this pre-hashed string from the hash by doing this, by pre-adding this key and copying it. And this restores performance to when you just type your hash key, literally in the Perl program. How can this be achieved with XS? A bit more about why it's important. So, having a pre-hashed value for a string really helps performance. So, using the API whenever you pass to which we come on in any form scalar value with possibly precomputed hash is always a win. You don't always control does the string has a precomputed hash or it doesn't, but you can assume that any literals written in a Perl program have them, like this literal, it's precomputed. Any literal string mentioned in compile time is precomputed. The downside of using this API at compile time. No, it's about how every hash uses this precomputed value. The downside of always using APIs when you provide a scalar value to hash operations is complexity. For example, this is a common constructor written in XS. You write type map for a foo class and just create it, and that's all. Like six strings, 6 lines of code. But this form, using the default type map for objects, translates into this. You can view this by executing make and then looking into the C source file. It fetches its first argument as a character, as a character pointer, and so it always down from here uses character pointer and not precomputed hash, and you can't make parse_access do otherwise. If you want to use fast and efficient ways to blast your objects into something, you have to write the same code by yourself, either by preparing a different kind of type map or some code generators or something else, but you have to change this argument from being char pointer to being scalar value pointer and use different form of less. And this complexity comes with almost everything. You trade speed for complexity. It's almost always a general rule. You can't have both. So when optimizing, you have to first profile and then decide is it worth it or not. Is it worth changing your patterns, since you will have to change all your type maps from accepting chars, integers, anything else to scalar values. So how can we have those fancy pre-hashed strings in a pure XS? When you get the string from Perl, sometimes it's pre-hashed, sometimes it's not. You hope it's pre-hashed. but can we create those strings in a Perl access, for example, when you store some values internally for your own use? Yes, you can. There is an API function usWebEvent share that returns you new scalar value with computed hash. And the common idiom when you have a static variable for it and store it in the boot section of your access file. There is one caveat in this, that it's not a thread-safe code, since whenever you are cloning a thread, all your old pointers may become invalid at some point in the future. So you will have to, if you are writing for a threaded Perl, you have to clone this value in a clone subroutine. Generally, creating threaded access code is complex, and whenever I can, I prefer not to do this. I've created some fully thread-safe modules and things like this. When you write it and you think it's okay, it's static. What can go wrong? But you can load modules not in the main thread. You can load them anytime. And if someone loads module and then loads another module and drops the previous thread, you get a crash. So beware. What's next about hashes and those pre-computed shared hashes? The result from this function will always yield you the same character pointer for any number of calls. You can call this 3 times in a program, and the resulting character pointer inside the scalar value will be the same. So you can use this for a fancy trick. String comparison is slow, since you have to iterate over memory and check string length and so on and so on. So when you can change string comparison to just a pointer comparison, it's a huge win. This shows how can you do this. If you are sure that the keys of this hash are always pre-shared, if you store them in this way, if that's your internal data set, data storage, you can change string compared for pointer compare. It's not always possible if you ever pass this hash structure to a Perl code, since it cannot do anything with it. So you will have to wrap it into your internal API that ensures that the keys are always shared. Yeah, but if you are, for example, if you have a hash consisting of 3 keys like ID, name, and age, and sometimes you have to iterate over all of those values, like to export them somewhere, and you can do 3 fetches, which are slow. You can iterate over hash and check for equality, which is faster, or you can iterate over it and just do a pointer check. Of course, you can do a trick like you can check only the first letter of a key if you are sure that there are no other keys except for those 3, and they happen to have different first letters. But that is guaranteed. And again, in those cases, you'll have to maintain your own API over this data structure. And maintaining your control over data structures used in excess is always beneficial, since whenever anyone ties a structure, when anyone puts a overload in a structure, it makes its usage slower, and sometimes significantly slower, and makes many of those feature tricks impossible, especially tie. Perl, for example, this itNext or itInit, it supports tied hashes. It supports any type of the Perl structure. You can pass it into it, but if you know that this is your own structure, you can bypass those checks. Since the tight checks is performed on each iteration, if you have a hash or an array of 1000 elements, this tightness check will be performed 1000 times, and you don't need this. You're sure it's not tight, or it's tight just only once. So don't use tight hashes. What is next? Whenever you store something in a hash and you don't care about the value you store, you just store it as a marker. Sometimes I see code that, okay, let's create some marker for it. But this is inefficient. You allocate a new scalar value for each entry, and then you will have to free them sometimes in the future, but why bother? It's just a marker. You need something in there, so you can use just something. Perl has pre-allocated scalar value for undefined value, so you can just store it, and it works just fine. There is some problem in storing this in arrays, since it has a special meaning, so it's suitable only for hashes. And you can increase it, you can decrease it. It won't ever die. It's immortal value. There are 4 immortal values in Perl: undef, yes, no, and placeholder. And you can use any of them except for placeholder and hashes, and undef in arrays. To indicate any like markers, or you have 3 values generally. So if you need ever to store less than 3, it's common idiom for storing just 1. You can use this trick. And the problem with arrays is not in reference counter, but in it means not allocated slot, if I remember correctly. Again, when we are iterating over something, what's wrong with this code? It's perfectly legal code. It does what's intended, but what's wrong with it? Sorry? No, but it won't upgrade the key itself. No, I'm only fetching it. Yeah, but I'm only fetching it. I'm not storing it, and I can't upgrade the key itself. The key itself is a character string, and this is a model copy of it. Here, by using its keys, I just create a model copy. Like in the previous example, I'm creating on each iteration a new scalar value, and here again I'm implicitly creating it. It doesn't seem obvious from this API usage, but it is. So reading the API docs, understanding what exactly each function does is really important. What to change this into? You just use some parsing. You just pass the key to A to I, or to grok number from the Perl API if you want to an exact compatibility with what Perl does. And you pass there just directly the key from each entry. Now about some things that are not possible in a pure Perl, but possible using the XS interface. Sometimes you want to get the field, or you want to initialize it if it hasn't been there. In Perl, it's always 2 operations. You always first check existence, and then you do either fetch or store. You can't do both in a single operation. You can fetch the value and then check for definiteness, but it's a different semantics. There are can already be stored in a defined value and you'll overwrite it. So how to do this efficiently using just one hash lookup in excess? You can write this code. You can just and again the default Perl interface for accessing hashes using scalar value keys is this, with the AND suffix and key here, and it returns hash entry. Whenever you use API that supplies characters, it will return you scalar value. So it's sometimes an inconsistency. You have, if you are going to change your code, you have to not only change the call side, but also how do you access the key structure from here, the value from here. But this is not exactly the analog of this. This one means that I want to add value if it wasn't present there. This is more like what I've described as getting as just accessing the value and checking it for definedness, since here we have no way to understand was it present in the hash previously or not. Since the Perl, when you pass this one, it's a flag, a value flag, to which we come on, it creates a variant for you, but luckily starting from Perl 5.16 or 5.18, we have a fresh new flag. We have a fetch empty here, and this code does exactly this in just one hash access, which is twice as faster as doing this. But this flag isn't exported in any wrappers, so you have to write more code when you want speed. And this also eliminates one problem with this. When you just ask for an null value from hash and overwrite the value, you have a memory leak. The value that was present in HA before you assigned to it, even if it wasn't there, if it was just created for you, it's not mortal. You have to manually decrease its ref counter. So this is just a bug fix for this, and this is the fast and correct version finally. And here you don't have to decrement the counter since there was null. But again, if you exit from here, if you don't assign here, you'll get a segfault.
In the previous one where you were decreasing the reference count, couldn't you have just set the existing SV that was in this line?
That's slower.
Okay.
I'll talk about this. Yeah, and calling SV set as V is always slower than just copying pointer to it. You just copy a pointer. Even if you increase or decrease reference counter, it's even faster to free in SV and then do this than to do SV set SV. What else do we have? Okay, so subroutine calls. Here we have two excess subs, old foo and foo. And let's call old foo from the new one. What can here be optimized? Any suggestions? Micro optimized. Yeah. That's the first one. And the second one is this flag. It's a very convenient flag. You don't have to care about what gets returned from here. But internally, it's implementing using by creating a separate scope for this call, and creating and then destroying the scope is slow. So it's faster. to pre-extend the stack for any number of elements you'll need, push them, and then call this with gscalar and just pop one element of the stack.
Is there not a way you could just call old foo directly?
Yeah, that's the next step. Why do you need all those not so fancy things when you just can do this? Just refactor the thing. But this is the code I've seen on CPAN, and not once. So that's why I especially bring this case from attention. So let's go next. Okay, more stack manipulation. The common idiom, not one of the common idioms for accessing the stack is the st macros, which allows you to access the stack elements independently of where you currently are, where does your current stack pointer point to the beginning, to the end, in the middle. But it involves an interpretable variable access, which is on non-threaded builds acceptably slow, but on threaded builds it's really slow. So if you can rearrange your code so you don't have to access stack elements by their absolute position, but only by their relative position, it's much faster. But this requires code change, sometimes even logic change. You have to do some things before and some things later that you could previously do in one place. This is about SV set SV. There is another reason why I sometimes see its usage. Let's suppose you have this code, this excess code. It has one problem. It doesn't correctly maintain reference counter on this variable. You will get double free unit, or use after free, which is sometimes worse. So when people do this and think, oh, Perl just screams at me with some major cryptic words, let's just do SV set SV and initialize it, pre-initialize it somewhere, and then it'll destroy you, since you have to destroy it here too. And this works, since the reference counter for this remains constant. But SV set SV is slow. If it already has enough memory, it can be okay-ish, but it's still slower than just a direct reference assignment. But you have to adjust the reference counter, so that's the difference. Here it's adjusted and here is not. And here I use a special form of inc with two additions, simple and nn, and I've forgotten void in there. It's inc simple void nn. This stands that simple for you can evaluate this argument more than once. Void, it doesn't need the return value, and nn, it doesn't need a check for null. So if you're sure what you have as an argument, you can shave some time, but by using longer but more suitable form for you. But the general form always works. So again, there are a lot of such hidden gems in Perl API. Now about some digging deep into data structures. Whenever you have an array and you want to iterate over it, you do something like this. And if your array is large, array of connected clients, like thousands of elements, you again perform tiredness checks on each of those iterations. But if you are sure that your client's array is not tied, or you control it, or you just don't care if someone ties it, you can do it in this way, you can just access the internal array representation and iterate directly using pointer arithmetics over it. The downside of this, it's not a public API. Perl doesn't guarantee you that the next version it won't break it. But it seems unlikely that the internal representation of an array ever changes from being an array.
Isn't it as simple, though, as to, I mean, checking for magic should be as simple as checking the flags on the base.
But you do this on each iteration, on each access to the element. You check the tightness magic on the array.
Well, you figure out if it has a magic, which is cached in the base.
Yeah, but that's a condition, and modern processors predict conditions, and they almost always predict them correctly. But if you step on a misprediction, it's better to not have condition at all. It does not give a chance for the processor to misinterpret it.
So would putting unlikely there fix that problem?
It's in the Perl code.
Yeah.
No, it won't. Unlikely are just hints for the compiler, not for compiler, not for processor. Processor just assumes that if you do a jump back, it's more likely than jump forward, but it isn't guaranteed at all. Intel, after all those vulnerabilities, discovered things. Oh, okay, let's revamp everything, and all those hints become irrelevant, or not. So you can save time. You can save time in execution by applying algorithmical structural changes, by doing major work like using pre-computed hashes, or you can also do this by those small things. And if you have really a lot of iterations, it will show. It depends on how far are you ready to go this road.
Yeah, if length is never greater than 5, then you're really not that worried.
Yeah. So, in general, avoid tie. At all costs, any tied variable will slow down any access to it anywhere. Furthermore, if you cast magic on a variable, if it's not a getter set magic, Perl will set a magical flag on it, and this magical is for overload. This magical flag will start a tightness check. It will search the magic linked list to check if there is a tie magic or not. So if you are applying a magic to a variable, but it's not a tie magic, it's not a get magic, it's not a set magic, just clear this flag afterwards. It will change nothing for the Perl itself, but it won't slow down the access to these variables. Avoid overload. Overload is a nice feature. It's nice syntax feature, but access using overload is twice as slow compared to method calls. And from excess, you won't be able to call overload easily anyways. And then there's a rather complex technique by creating custom opcodes. 2 years ago, Sawyer had a talk in Cluj about refutil module, and I have a link for this talk in the end. It's a great talk, so if you're interested in those techniques, you can view it. Yeah, so another good talk is by Bulk88. It can help you to understand the stack arithmetics, what happens with stack pointers, with calls. Sometimes you can the full here it is. This is the full method call. Push mark, push some values, store stack pointer back, create scope, do the call, get the pointer back, leave the scope. Sometimes you can omit everything from here except the push mark. For example, if your function is just a proxy, you get some parameters, do something under irrelevant, or just check those parameters, then you need just only stack pointer, you don't modify it, you don't need to put back it. You just don't care where it ends, and that's all. That's the only really required operation to perform a method call. And creating those scopes can cost you on very simple functions like 50% of their execution times. I've created an accessor library when all those optimizations stack together give you like on pre 5.24 pearls performance comparable to Perl's original hash access speed, and in 5.24 Perl greatly optimized hash access, so good job. And it again became like 4 times faster than any XS accessor.
I'm going to make you repeat that. So are you telling me hash access is, or rather method lookup is...
Hash access in modern Perls is 4 times faster than there is no method lookup in those accessors.
Okay.
So then accessor usage, not method lookup.
So like accessor?
Yeah, and in pre 5.24 Perls, they are comparable. Accessor access is like 30% slower than a direct hash access. But there is no there is in those accessors, there's like those tricks included. There are code manipulation. There's runtime of code manipulation. So there are only one lookup really if you end up in a good code.
Well, they have a hidden cache too.
Yeah, but in good no, that's in the class accessor case. I even don't hit that cache. In object accessors, I hit that cache, but with precomputed values and so on and so on and so on, in just once. So, any other questions? We have how much time do we have? 12 minutes. So a lot of questions. Okay, thank you. You can catch me after the talk and drink coffee.